Hi, so this session is on now quadratic graphs, and we know a quadratic graph, its shape is called a parabola, and we're going to learn how to start plotting parabolas. But before we do this, there are a few keywords and concepts that we have to go through, and then we will observe these changes happening to our parabolas when we start drawing them. Now, the basic parabola is this equation here, y equals x squared. And if we compare this to the general quadratic equation, remember we have y equals, we can have ax squared plus bx. That should be x plus c. Okay, so that's the general quadratic equation that we have been working with. We know it's a trinomial. So the basic parabola, if you compare it, you can see that it only consists of this bit here. There's no x and no constant. Okay, and we can put an a in front of this as well if you wanted to. But that a is really a positive one, and it's important that it's positive. Okay, now if we had to draw this basic parabola, it will look like this. I'll just make that a bit straighter. As a quick sketch, this is what our basic parabola looks like. We've got our y and x axis. And that is something you just have to remember. Now, we're going to just have a look at some of these features of this basic parabola. Now, if I asked you to factorize this equation to find the x-intercepts, how would you factorize it? Now, imagine I wrote this as a trinomial. I would have this, y equals x squared plus, because there's no x and c, it'll just be 0x plus 0. So really we're left with the y equals x squared. But to factorize this, we can just use that quick method, get our brackets ready. We know we got x squared, so x times x. It's all positive, so plus and plus. And of course, what will go here? Well, we've got 0 and 0. So something times something to give us 0, that adds to 0, is just going to be 0. Okay? And if we make y equals 0 to solve this, we can see what we'll end up with. We'll end up with x equals 0, and solve this one, x will also equal 0. So we can see with this basic parabola, its turning point, or its x-intercepts as well, is at the origin. Okay, it's at 0. Now, the other thing I mentioned is that its turning point is also 0. Now, we know that every parabola has a turning point. And with parabolas, if I drew another parabola just here, okay, parabolas are symmetrical, which means if we cut them in half or divide them in half, each side is equal. Okay, so symmetrical means both sides are the same. Okay, so this space here and this space here are identical. They're just sort of like a mirror image. So this parabola here is symmetrical. I know it's not accurate, but we can see the y-axis is cutting the parabola in half. Okay, that is called the axis of symmetry. And the axis of symmetry is the x value of the turning point. Because the turning point is 0, 0, the x value is 0. Okay, so this axis of symmetry, we would say x equals 0. Now, we will come back to this later on. So if that confused you, don't worry. But just remember that a parabola is symmetrical, and we can cut this parabola in half when we have the x value of our turning point. Now, the y-intercept with our basic parabola is also 0. And to find the y-intercept, all we have to do is make x equal 0. So if I make x equal 0, I would have y equals, so there's our basic parabola. So when x equals 0, we would have y equals 0 squared, so y just equals 0. So with the basic parabola, we'll just draw it again. Everything is happening at the origin, okay? Where x is 0 and y is 0, that's its turning point. It's also its x-intercepts, and it's also its y-intercept, okay? So that's something to remember when looking at the basic parabola. That's where its position is. So let's just summarize what we've covered so far. So we've looked at the basic parabola, and you can summarize these points in your own words. So the basic parabola, we know it's in the form of y equals x squared. It's symmetrical. It has an axis of symmetry. And with the axis of symmetry, we will be coming back to this later on in case you're not sure about it. we've compared the basic parabola to the general equation that we can get, the trinomial. And when we factorize the basic parabola, we can see we end up getting the x-intercepts are clearly 0. And to find the y-intercept, well, to find the y-intercept, we make x equals 0, and that's pretty easy. So the features of a basic parabola are this. And this basically summarizes what we had, the information we have above. So if you just write this down, that's fine. So the basic parabola, its turning point is 0, 0 at the origin. It has a minimum turning point. We'll understand in a second what we mean by a minimum turning point. The axis of symmetry is where x is equal to 0. And like I said, we will come back to this. Y-intercept is 0 and x-intercepts are 0. Okay, that's pretty straightforward. So now the next thing we are looking at are what we call transformations. Now, transformations, think of the movie Transformers, and when they transform, what's happening? They're obviously changing into something else. I think there's robots and things in that movie. I haven't actually seen it, but so if you get stuck on if you see this word and get stuck, think of Transformers the movie, and basically it means there are changes happening. Okay, so we are now going to have a look and see the different types of changes that can happen to our parabola or to our basic parabola. So here is our basic parabola, as accurate as I could do it. So whenever you draw a parabola, it's important to put the equation next to the parabola, just so the person watching you, looking at your work, can see what the equation is. Now, I can easily make a change to this parabola. For example, I can have the exact same parabola, but instead of drawing it this way, I can draw it this way. Okay, so imagine they're exactly the same. It doesn't look like a parabola, sorry. But to do this, we have actually changed not its turning point, but we say we've changed its reflection. So that is the first thing we are looking at, the first transformation, and that is reflection. Oops, sorry, I'll just move that. So with reflection, there are two types of turning points we can have. The first one is that we can have a maximum turning point, or we can have a minimum turning point. So minimum turning point is what our basic parabola is. Okay, we can see how this parabola, it's going down. And to understand how this works, look at the y values. We're up here and we start going down. The y values are decreasing, getting smaller and smaller. Here it's 0, and then it goes back up. So the minimum turning point is this one here. Okay, and you can see how it's minimum. The turning point is the smallest value for y, and then it goes back up. Whereas the maximum turning point, you can see maximum turning point here, it's like a hill shape. It's got a highest point and then it goes back down. Okay, so just draw a quick sketch of this. And so this is our minimum turning point, and this one here is our maximum turning point. Okay, and you can see how this is like a hill, and that one is like it's a dip that's going low, reaches the lowest point and goes back up. This reaches the highest point and goes back down. Okay, so we can have a maximum or a minimum turning point. And the basic parabola has a minimum turning point. Okay, so that's what reflection means. Next thing we'll look at is dilation. Now, dilation may be a new word, but basically dilation refers to the parabola becoming more narrow or wider. And when this occurs, the turning point stays the same. It's just that the parabola itself is becoming more narrow or wider. So let's just do some examples. So once again, we have our basic parabola. And now if I draw another parabola like this, okay, you can clearly see this parabola, it's not the same. It does have the same turning point, okay, but you can see how it's more wider. Okay, so we can see how its dilation has changed. If I draw another parabola with the same turning point, so it's passing through the origin and goes back up, you can see how this parabola is different to our basic parabola, the one in blue, because it is now more narrow. And we can observe these changes happening. These three parabolas all have the same turning point. The thing that's changed is dilation. Okay, one of the parabolas, the red one, is wider. The green one is more narrow. And we're comparing this now to the basic parabola. Okay, so when this happens, we can say the dilation is changing. It's either becoming more narrow or becoming wider. The next thing we are looking at is translation. Now, translation doesn't refer to translating. I'll just delete, I won't delete this. I'll just move this up. Oops. So translation is another transformation that can happen. So remember, all these things here are under the category transformations. So the changes that can happen so far, we've looked at reflection, and we can have a maximum or minimum turning point. We've looked at dilation, where our parabola can become more narrow or wider. And now we're looking at translation. So translation now is where the turning point actually changes its position. And the types of translations we can have are vertical translation or horizontal translation. So let's have a look at those two. So once again, we have our basic parabola, and I'm going to draw another parabola just next to it. Let's see, I'll put it, so it'll be, imagine I grab this parabola, the basic parabola, and I drag it down here. So exactly the same parabola, but what has changed? It has gone down a certain amount of units. So this translation, we would say, is a vertical translation, and it's gone down a certain amount of units. If I drew another parabola, I'll keep it in red as well. Up here, imagine it's exactly the same shape as the basic parabola, same, you can say same dilation, sorry. You can see how it's simply now, it's shifted up, or it's been translated vertically a certain amount of units. Okay, so this is what we call vertical translation. So vertical translation, moving up or down. The other type of translation we can have is horizontal. And horizontal, so if you've forgotten these words, vertical and horizontal, remember vertical is a straight line, horizontal is a horizontal line. And the way I remember is H in the word horizontal, if you have a look, it has a horizontal line. There it is. Okay, so horizontal means our parabola is changing position. It's translating either left or right. So let's draw our basic parabola again. We've got Y and X. There's our basic parabola. And now if I drew another parabola, imagine I got my basic parabola and I moved it across this way. Okay, so it's still the same parabola, except it's moved now to the left a certain amount of units. And if I drew another one on this side, okay, it hasn't gone up or down. It's simply, in this case now, moved to the right. So this is what we call a horizontal translation. Either moves left or right, a certain amount of units. Vertical translation, it moves up or down a certain amount of units. And of course, you can actually have both that happening at the same time. For example, if I draw a parabola here, just quickly, it can be blue. If I drew my basic parabola up here, you can see how it's moved to the right and also moved up a certain amount of units. So with translation, we can have vertical translation happening only, we can have a horizontal translation happening, or we can have both happening at the same time. And it all depends on the changes that happen to this quadratic equation here, to this basic parabola. Okay, so our next session will be on observing these changes when we actually change the quadratic equation. So please make sure you have these important points down. Just go back if you haven't written any of these down and pause it. And we'll observe these changes, but it's important to understand what these keywords mean. Okay, so with transformations, once again is telling us that our parabola is changing. Okay, and the changes that can occur, one, reflection. Okay, our basic parabola has a minimum turning point. This can also turn into a maximum turning point. Okay, and information here actually tells us what happens. If there is a negative in front of the x squared, okay, there's our basic parabola in its equation. You can see a negative, okay, just there. This is what makes a parabola actually have a maximum turning point. and minimum turning point, the coefficient in front of x squared has to be positive. Now, dilation is where instead of reflecting, it's now either getting wider or more narrow. That's what dilation refers to. And translation is where the parabola, its turning point, actually moves. So we could have a vertical translation, moving up or down, or we can have horizontal translation, moving left or right. So please make sure you've got these keywords and concepts written down. Thank you.